Hi, you might be wondering, what does the game you just played have to do with quantum computing? Well, I'm here to tell you. If we look at this from a historical perspective, classical computing and quantum computing are very different, which is why the computers themselves are very different. For classical computers, they were designed to accelerate mathematical operations that you and I do every day. And so even as technology changes, the basics of a computer is the same. And so it started with numbers, and then we realized that sound and pictures and lots of things can be expressed with numbers. And so we could do more than the original ideas. And then we can also store lots of information. And so that's the Google transformation with data, search engines, Google Maps, traffic, all of that. Quantum computing is very different. It starts out with a phenomenon that turned into building a technology. So we have superposition and entanglement, things that we haven't seen the actual terms for yet, but you actually might have gotten to superposition in your game. And only after they discovered that, they said, well, is there any computing that we can do that would be different from classical computing? And then, is there anything we can do that's faster than classical computing? So quantum computing doesn't do math faster than classical computing. It does something very different, which is what you tried out in the game. So let's look at a real quantum circuit. Look at this. This looks a lot like the boxes you saw in the cupcake game because we based the cupcake game on real quantum operations. So we can see that on the left are these symbols 1 and 0. All computers store data at the lowest level at ones and zeros, and all of the other numbers are made up of ones and zeros. So these chocolate and vanilla cupcakes are representing our ones and zeros. And so these real quantum operations can be applied, and we can actually calculate what the result is. The big difference between what you're seeing in this quantum circuit and how we interpreted the conveyor belt is that in quantum computing, we're not moving the cupcakes through devices. The devices that you see, or operations, these symbols are just the order in which operations are going to occur. No movement necessarily takes place. And so these boxes are trying to show the sequence of operations that occur as opposed to where a cupcake travels through the system. So we can calculate these just like you did in your game, and I would get my results, my intermediate results, and then my final results. So this is what quantum programmers can do when they're trying to solve problems. So what else can quantum computers do? Well, quantum computers can store so much more data than classical computers. That's one of the huge advantages. Another advantage is these different operations and what you can solve with these different operations. There is a downside. Quantum computers are still new and they have a lot of errors. So classical computers have less than one error in every 10,000 million operations. Whereas current quantum computers have one in every 1,000 operations. Now that's sort of a problem because classical computers operate on over 1 billion operations a second, which would mean that if that was a quantum computer running at that speed, that would be over 1 million mistakes per second. So quantum computers are not ready for prime time quite yet. If you want to learn more, feel free to go to our website.